my pleasure to welcome you to this presentation titled Sensors Avoid Material and Energy Wastage. In a world where sustainability is becoming increasingly important, finding ways to reduce material and energy waste is crucial. This presentation will explore how sensors can be utilized to achieve this goal. Sustainability is a multi-phased concept that includes social, environmental, and economic dimensions. Each of these dimensions is essential to achieving long-term sustainability, and businesses must take them all into account when developing their strategies and products. In the case of sensor providers, the three dimensions of sustainability can be met through the purposes of safety, process control, and quality assurance. The first dimension of sustainability is social sustainability. Safety is a critical purpose of sensors. They contribute to social sustainability by ensuring that people and workers are protected from harm, detecting potential hazards, and reducing the risk of accidents and injuries in the workplace. The second dimension of sustainability is environmental sustainability. Process control is another purpose of sensors by, for example, monitoring energy use, water consumption, and other resources in real time, allowing businesses to optimize their processes and reduce their environmental footprint. The third dimension of sustainability is economic sustainability. Quality assurance is a purpose of sensors by ensuring that products and processes are efficient and effective. By monitoring and analyzing data in real time, sensors can identify areas of inefficiency and help businesses optimize their processes. This can lead to cost savings and increased profitability, which can contribute to long-term economic sustainability. At the bottom of this slide, you find some examples. With Webmaster Falcon Eye, people are safe because our sensor helps assuring zero defects in airbag and seatbelt production. With Webmaster SFB, the web thread tension is controlled in the weaving process. And the purpose of YarnMaster Prisma is the final quality assurance of the yarn. For the purpose of this presentation, I would like to focus on how YarnMaster Prisma can be the driver for sustainable economic decisions. YarnMaster Prisma is Loepfe's yarn clearer for the highest requirements. The sensor is made up of 4 different technologies: optical infrared, capacitive mass, and optical RGB, and triboelectric. By analyzing data in real time, it is possible to fully monitor the yarn. This includes properties like defects, yarn contamination, and yarn throughput. The customer benefits from the system through increased flexibility in achieving high-quality end products, improved profitability by reducing yarn and energy wastage, and increased productivity by reducing the number of cuts per kilometer of yarn. Here you see the winding process that runs at a speed of up to 120 kilometers per hour or 2,000 meters per minute. With a sampling rate of 2 millimeters, a total of 500,000 data points are recorded on just 1 kilometer of yarn, then processed. A decision is made within fractions of a second on whether a defect can remain in the yarn or must be cut out. The decision on whether a defect is tolerable is based on the settings which are made by the quality manager. Over the next slides, I would like to give you a practical example of how sustainable decisions can be taken. In a field study, we compared Yarnmaster Prisma with Yarnmaster Zenit as a conventional clearer. Yarnmaster Zenit is a widely used yarn clearer 2 generations before Yarnmaster Prisma. The target of the study was to prove the better performance in clearing in regard of fewer cuts and better fabric quality. Details of the study were 100% cotton from India, NE30 carded compact yarn was spun, and an NE40 compact yarn was spun. The trials were done on the same winding machine. Here you can see an example of a so-called clearing matrix for short and long, thick and thin places. By shifting the curve, the quality manager makes a deliberate trade-off between more clearing and thus less throughput on the one hand, or otherwise less clearing and thus more throughput. The consequences of this decision will also influence the final fabric's appearance. In the first step, I would like to show you the results of the clearer cuts from this field study. For seldom occurring thick and thin places, call it NSLT, up to 36% fewer cuts were reached. For foreign fibers and polypropylene, up to 69% fewer cuts were reached. Both cut types together result in a 64 for NE30 or even 132% lower cuts for NE40. These are tremendous improvements in technology. Now, of course, one could assume that a lower cut rate will cause faults to be overlooked and left in the yarn and in the fabric. So in the next step, we checked the yarn by processing it into a knitted fabric. The knitted fabric was inspected and evaluated for its remaining contaminations in the fabric. The results confirmed that the number of contaminations per kg of fabric is almost 40% less with the latest clearer generation. This means fewer cuts while reaching even better fabric quality. This is achieved by the most accurate measurement technology and intelligent cut management, which is designed to trigger cuts in a coordinated manner. However, new technologies are ultimately judged on the basis of their financial aspect. Let's have a look. Quantitatively, the following savings can be realized. I think something is missing on the slide. Okay, so savings of a yarn waste, that is probably the yellow part in the slide.
You can see.
Yeah, but here the legend is savings of energy and compressed air and higher productivity. Savings between 2,500 or 3,000 US dollars per year per machine will add up to 65,000 US dollars savings per year for an average size spinning mill. At the same time, the clearer gives the quality manager the assurance that nothing has been overlooked and that the yarn has been optimally produced. But also qualitatively, the new technology can have an impact in the following areas. Potentially a higher yarn price due to better yarn quality, leading to higher margins. Reduction of splices, which lead to better unwinding properties on the cones in the next process steps. And a higher fabric quality with fewer remaining faults. This proves that high-tech sensors from Loepfe with intelligent functions are the basis for sustainable production and economic decisions. At the end of my presentation, I would like to summarize. Sensors that are well placed in the production process have a direct impact on the three dimensions of sustainability. Loepfe sensors are built on the latest technology. Mill and quality managers have full flexibility in balancing targeted yarn quality versus production. Through deliberate settings of Yarn Master Prisma Clearer, savings of multiple 10,000s of US dollars can be achieved per year at the mill. Loepfe develops sensors and actuators to support machine manufacturers and production mills. New sensors and developments, such as those presented at ITMA 2019 and ITMA 2023, continuously set benchmarks in quality control. See you at ITMA Milan. Thank you very much.